I in aviation. Here you go. Same structured format for AI in aviation. I in aviation. Intermediate means advanced, intelligent air systems. Introduction. Aviation focuses on aircraft design, flight operations, air traffic management, safety and maintenance. With artificial intelligence, AI, aviation is evolving into autonomous flight systems, predictive maintenance, intelligent air traffic control. AI is transforming aviation into safer, smarter, and more efficient air systems. What is AI in aviation? AI in aviation refers to using machine learning and intelligent algorithms to improve aircraft operations, safety, navigation, and maintenance. In simple terms, AI in aviation equals smart systems that help aircraft fly safely, efficiently, and autonomously. Example concept. Flight data means AI model means optimization, safety decision. Why AI in aviation is important? AI is important because it improves flight safety, optimizes fuel efficiency, enables predictive maintenance, enhances air traffic management, supports autonomous flight. Without AI, manual systems means slower decisions means higher risk. With AI, AI-assisted systems means real-time decisions means safer flights. Key components of AI in aviation. 1. Flight data, sensors, cockpit data, telemetry. 2. AI models, prediction, optimization. 3. Aircraft systems, avionics, control systems. 4. Ground systems, air traffic control. 5. Communication systems, aircraft ground communication. AI in aviation architecture. Key layers. 1. Data collection layer, sensors, radar, telemetry. 2. Data processing layer, filtering, analysis. 3. AI model layer, prediction, decision making. 4. Control layer, flight adjustments. 5. Execution layer, aircraft systems. How AI in aviation works. Workflow. Collect flight data. Down pointing arrow. Analyze in real time. Down pointing arrow. AI model prediction. Down pointing arrow. Decision making. Down pointing arrow. Execute control actions. Example. Conceptual. Def optimize _ flight. Data. Return, adjust altitude. Print. Optimize _ flight. Flight data. Key technologies used. 1. Machine learning, predictive analytics. 2. Deep learning, image and sensor data. 3. Computer vision, runway detection. 4. IoT plus sensors, real-time monitoring. 5. Autonomous systems, self-flying aircraft, real-world applications, autonomous flight systems, self-flying aircraft, intelligent navigation, reduced pilot workload, predictive maintenance, detect failures early, reduce downtime, improve safety, air traffic management, optimize flight routes, reduce congestion, improve safety, fuel optimization, optimize routes, reduce fuel consumption, lower costs, safety and risk detection, detect anomalies, prevent accidents, enhance safety systems. Advantages of AI in aviation. Advantages include improved safety, real-time decision-making, reduced operational cost, enhanced efficiency, automation of processes. Example concept. AI means smarter aviation means safer plus efficient flights. Challenges of AI in aviation. Challenges include strict safety regulations, system reliability requirements, high implementation cost, cybersecurity risks, integration with legacy systems. AI versus traditional aviation systems. Traditional aviation, manual control systems, reactive maintenance, limited automation. AI-driven aviation, intelligent automation, predictive maintenance, autonomous systems. Comparison. Traditional means manual plus reactive. AI-driven means intelligent plus predictive. Best practices. Ensure safety first. Critical systems. Use high-quality data. Improve accuracy. Validate AI systems. Reliability. Combine AI plus human oversight. Better decisions. Follow regulations. Compliance. Future of AI in aviation. Future trends include fully autonomous aircraft, AI-driven air traffic systems, smart airports, advanced flight optimization, improved safety systems. Example concept. Future means autonomous plus intelligent aviation systems. Concepts learned from AI in aviation. Understanding this helps learners understand. Checkmark how AI improves flight safety. Checkmark how predictive maintenance works. Checkmark how air traffic systems operate. Checkmark how autonomous systems function. Checkmark how AI integrates with aviation. Simple definition. AI in aviation. Using artificial intelligence to improve flight operations, safety, and efficiency. Final summary. AI in aviation transforms systems into intelligent, automated, and safe air systems. It enables autonomous flight, predictive maintenance, optimized air traffic, improved safety. It is essential for modern aviation systems, airline operations, smart airports, future air travel,